Hi, it's Fazana here, making you sharper and stronger with every video you watch. Is that a deal? Good. In this video, we look at some circle theorem questions, and I'll show you how to approach these questions no matter how complicated they look. The trick to circle theorem questions is to make the diagram your own, even before you hit the questions. So, by the time you're actually done, before you even started reading the questions, you've actually got the answers. Yeah? As important as the circle theorems themselves, always remember to mark your radii. Once you do, it'll be easy to spot any isosceles triangles. Let's have a look at some questions. Okay, the diagram shows a cyclic quadrilateral ABCD. Okay, that's really nice of them to tell us. Okay, so, oh my God, that's your cyclic quadrilateral. So 37 plus 46 is 83. So you know that angle and that angle, opposite angles in a cyclic quad come to 180. So you know that's 97. Yeah? Okay. So can you see how much we've already done with that? Yeah? ADE is a straight line. Okay, so AD is a straight line. Great. So that must be 180 minus 97, which is 83. So that's 83. Good. So you can see the 3 there. Okay, so we've done something with that as well. CE is a tangent to the circle. So you can tell that that's the chord, yeah? So the angle between the tangent and the chord, yeah? So here's our alternate segment. That angle will be equal to, that angle there. Okay, so that's 46. Okay, so we're getting closer to this x that we're trying to find here. Okay, okay, if that's 83, that bit there, and that's 46, don't we already have that? Oh my God, it couldn't have been that easy. Okay, 180 minus 46 plus 83 equals 129, which is 51. Okay, so it was that easy. Yeah, all right. So the first thing we did was say that 97, yeah, which was A. So A and the reason, of course, always get the reason. So opposite angles in a cyclic chord. Of course, you have to write the whole quadrilateral. Yeah, add up to 180. Okay, and then what we did was that one there, so B. So you say angle CDE equals 83, and the reason being angles on a straight line, and of course you have to write the whole thing, equals 180. And then that one was C. Yeah, and then again you have to write the whole thing, but I'm just writing alternate segment. So you've got to write the whole reason. Angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, yeah? All right, let's just play around with it. I know it's not part of it, but there's just so much I can see here. So it's a real good learning thing. Can you see that's your bow tie there? Yeah? So if we just play around with it, then you can tell that that angle there will also be 46, because angles in the same segment or extended by the same arc. Yeah, so that's just an additional one. Okay, so this is just like learning it. Yeah. Anything else that you can see? That would make life interesting. Okay, just thought I'd point that one out to you. All right, yeah, okay, good. All right, let's move on. Okay, A, B, C, and D are 4 points on a circle, so we know we've got our cyclic quad. Yeah, so that angle and that angle will be 180, or that angle and that angle will be 180. Okay, cool. We've got a center here. The minute I have a center here, I make sure I mark my radii, because then you know that's going to be an isosceles triangle. Okay, so it's like you're one step ahead. Yeah, all right, cool. And the other thing I can see, so you can see I've hardly read anything and I'm already playing around. So here, can you see that's the angle at the center is twice the angle at the circumference? Yeah, all right. Okay, so I'm aware of that. So PBA is a straight line. Okay, so let's do that. And angle PBC is 100. Okay, so that must be 80. And this is when the cyclic quadrilateral kicks in. So that whole thing is 100. Okay, good. Okay, CE is a tangent. Where is CE? Sorry, I think the diagram sort of didn't copy properly. So that's CE. So C is a tangent, so you know angle between the tangent and the chord. But we've also got a 90-degree angle here because radius meets tangent. Yeah, angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, do we have anything here right now? Okay, let's just go by what we've done. Oh, DAC is 23. So that kicks in there, so that's 46. Yeah. Okay, and now what else can we do? Oh, that angle there we can calculate. Yeah, okay, but let's just continue reading the question. Show that size of angle OCA. So OCA, so that little bit there, yeah, is 10. Okay, all right, we've marked our radii, so we know that angle, that whole angle there, yeah, will be 180 minus 46 divided by 2. So 180 minus 46 is 134. So each of the angles will be 67. So that whole thing there is 67. Okay, yeah. And remember how I said we can play around with that triangle there. So that bit of it is 57, because 100 plus 23 plus 57 is 180. So we can tell OCA would be the 67 minus the 57, which is 10. Okay, yeah, all right. Okay, let's give reasons. Yeah. Okay, so what we first did was we were told that, so that was that. Yeah, so that's number 1 there. Okay, and then you go angles on a straight line equals 80. 180. Yeah, good. And then what we did was that one there, so angle ADC, so that was 2, and then angle opposite angles in cyclic chord equals 180. Yeah. What did we do next? We'll assume that we've already written that, yeah? So then we'll go for this one here, yeah? So that one is 3 and 3, angle at center, twice angle at circumference, yeah? And then we talk about the isosceles bit, okay? So then we'll say that bit there is 67. So that's number 4. Because triangle OCD isosceles, 2 radii, yeah, okay, and then we talk about that angle there, number 5, is because of triangle DAC, come 280, yeah, all right, okay, and then you just talk about that one there. So 67 minus 57 equals 10 degrees. Okay, yeah, and you can see that would be like a 6-mark question. All right, yeah, okay, so just work with it. As long as you know your theorems, you find that you're seeing things as you're reading them, yeah, all right? And if you can't, then just continue reading them and something will fall out. But always make the diagram your own. Okay, yeah, good. Okay, in the diagram, O is the center of the circle, okay? So then immediately I'm thinking right angle there, yeah? I'm also, so can you see from the center, so much of my theorems just come to my head. So you can see that's the diameter, so that's 90. Yes, I'm marking all my 90s, yeah? And then I can already see the bow tie, so I know that's also X. Okay, yeah, so much from there, right? Okay, find in terms of X the size of these angles. So, okay, let's go ADE. Tell me we have it already. ADE, we sure do, equals X. And the reason, angles extended by the same arc or angles in the same segment. Are equal. Okay, yeah. B, angle DAE. Have we got it? DAE. Okay, so in terms of X, that's 90. You know they all come to 180. So this bit here will be 90 minus X. Okay, and you just say angles in triangle ADE equals 180. Yeah, all right. EAB. Okay, EAB. Ah, all right, there's a tangent there. So you can see the angle between the tangent and the chord is equal to the angle in the alternate segment. So that's X. And you have to write the whole thing. Alternate segment. And then D is AOE. Okay, where's AOE? AOE. Ah, so we have to draw that line there. Yeah? And can you tell again? We've marked our radii, so we know that's an isosceles. Yeah? All right. That bit is 90 minus X. So that bit there will also be 90 minus x. Yeah, okay. So what we're really doing is we're going 180 minus 90 minus x minus 90 minus x. Yeah, and you can see 90 minus 90 will disappear, and then you've got minus x, so you've got minus 2x. Yeah, okay. Okay, something didn't quite work out here. Let's just check it, because when I look at that, I can see angle at the center is twice the angle at the circumference. So that should be because, can you see by looking at the question, keep looking at the question, yeah? You can actually see it. So you've got 180 minus 180, and then you've got the minus and the minus, so then you've got 2x, yeah? So you've got 180 plus 2x, okay? Always just keep checking. So if you do make a mistake here, you're actually learning from my mistake, yeah? So that would be 2x. So that was an even easier way of doing it, yeah? So then you've got 2x, and then you go angle at center twice angle at circumference. Okay, yeah? As I said, can you see by making your diagram your own, if you're making any mistakes, it's going to really jump out at you, because while you're writing things, you're still always looking at it, yeah? And you can see your arrowhead. Okay, yeah, good. All right, cool. And sometimes, you know, when you make a mistake and then you can actually correct it, it makes you feel even better, because it's like you've accomplished something, which is being aware of your diagram, yeah? So it's not a case of being clever, you've actually proved you're smart as well, yeah? Okay, covering up the mistake. Okay, ABP and ADQ are tangents to the circle, center O. Okay, just hang on, okay. C lies on the circumference of the circle. Prove that y equals 2x. Okay, so that is the same, yeah? Okay, let's go ahead with it. So we can see that radius meets tangent, so let's just put in all our 90 degrees, yeah? So that's your 90 degrees there. We know angle at the center will be twice that angle, yeah? But we're not going to write any thing at the moment. And you can tell these are all isosceles triangles because we've marked our radii. Okay, yeah? Anything else you can see? Okay, for the moment that should be fine. Okay, so if that's 90, then you know that bit there is 90 minus 2x. Yeah? And because we've sort of marked this already, we know we're going to try and look for this bit here. So that will also be 90 minus 2x. And once you've done that, you think, well, I wonder what that bit there is. But you can see that's also an isosceles, so that's also x. Yeah? So in total, those two are 90 minus 2x plus x, which is 90 minus x. Okay, yeah? Now angle at the center is twice that angle, so that angle there will be 2 lots of 90 minus x. So it's 180 minus 2x. Okay, yeah? So that's 180 minus 2x. Okay, now we come to that one and we covered it when we did circle theorems. Can you see that's 90? That's 90. Yeah? So if we look at that quadrilateral, all four angles should equal 180. So if those two come to 180, then those two will come to 180. Yeah? So if you think about it, that angle, that 180 minus 2x, has to be the same as 180 minus y. Okay, so can you see the 2x has to be y? Yeah, all right, cool. It's good, wasn't it? Okay, all right, so let's do, what did we do first here? We did first that, and then we say radius meets tangent. Then we did that, and that was because it was an isosceles, 2 radii. Yeah, then we did this one here, and this was the same reason, isosceles 2 radii. And then we did this one here, angle at center, twice angle at circumference. Okay, and then of course we did that there, and we'll just say angles in quad equals 360. Yeah, so then therefore, oops, sorry, something's gone wrong here. Okay. Let's just fix this, sorry about that. Okay, so then we've got that there. Okay, yeah, all right, good. Okay, last question. Okay, the diagram shows a circle with center O. As I said, the minute you have that center, you're always looking for radius meets tangent, diameter, angle at the center. Okay, so everything comes to mind. So here you can see it's angle at the center. Yeah, so that angle there is 48. Okay, and it says work out the size of angle ACB. So we know that's 48. And again, if they asked us for the reason, angle at center twice angle at circumference. Okay, yeah. AB equals 16. Okay, that chord there. Work out the radius of the circle. So you can tell we need this those lengths, yeah? So you can see that's an isosceles triangle, if it helps. Okay, so you know that those angles there will be 180 minus 96 divided by 2. So that comes to 84. So each angle is 42 degrees. Okay, now when I look at it, I'm thinking I need to find a radius. So let's just look at that one right now. It's not a right angle triangle, so can you see again? They've combined circle, theorem, and advanced trigonometry. Okay, so we're trying to find that. Let's label our triangle. So that's A, that's B, and that's O. Okay, we need to find a side. In the cosine rule, you'd actually have to have a B opposite, so we don't have that. So let's see if we can use the sine rule. For a sine rule, we need the crisscross. So A over sine 42 is 16 over sine 96. Okay, So a over sine 42 equals 16 over sine 96. Okay, now using the Faz format of 3/6 equals 2/4, yeah, just two simple fractions that are equal to a half, yeah. We're trying to find our 3, and we know we can cross multiply because 3 times 4 is 6 times 2. So to find the 3, we go that times that divided by that, okay? So a will be cross multiply the others, so 16 times sine 42 divided by sine 96, and you do that on your calculator. We need it to 3 significant figures. You get 10.8 centimeters. Okay, so that's the radius. Yeah, that was all right, wasn't it? Yeah, beware of these combined questions, where they're combining two topics, which shows that you've got to watch every single video of mine. Yeah, and I'll go through the whole syllabus with you. Okay, now wasn't that a glorious experience? I'm sure you were waiting for some more questions, but you may now rest briefly. You've done well, my bright students. Keep working hard. It feels great and produces excellent results and an indescribable sense of achievement. Remember, you're in control. Until next time, take care. Bye.